Hey guys, Mr. Wilson here. Today we're going to look at similar polygons. At the end of this video, you should be able to determine whether two polygons are similar and explain why or why not. You should also be able to use similarity in polygons to find missing side lengths and angle measures. And you should be able to write a similarity statement and similarity ratio in similar polygons. Okay, so some vocabulary first. Two polygons are similar, and we use this little tilde like we had at the top of the congruency, except notice that with the congruency we had equal in this tilde. Here's similarity, just the tilde. Okay, so two polygons are similar if both of the following are true. All corresponding angles are congruent, and all corresponding sides are proportional. Proportional, okay. Big deal here, proportional, not equal. They don't have to be equal to each other, but they have to be in the same proportion. Okay. So the difference between polygon congruence and polygon similarity is the proportional aspect here. Okay, they don't have to be the same, but all the sides have to be in the same proportion, the same ratio. So a similarity statement is a statement that of two polygons that are similar. Okay. This is very much like a congruent statement. The big difference is the similarity ratio. Guess I could have just said ratio. Okay. And the ratio is the ratio of the corresponding sides. Right? There would not be a need for ratio for angles, since angles are corresponding angles are going to be the same. They're going to be congruent. Okay, but the sides are not necessarily congruent. So let's look at some examples. It says, find or fill in the missing angles and sides given that ABCD is similar to EFGH. Okay, important here that we remember that our similarity statement will trump the appearance of the diagram. So EF corresponds with AB. Okay, so here we're not given numbers, right? We're only given the names of the things. So we need to make sure that we're using those corresponding pieces. So the measure of angle E, look at E, it should be the same as the measure of angle A. Number two, the measure of angle H should be the same as the measure of angle D. Okay, here it says AB over BC should be the same as EF over FG. DC over HG, right, should be the same as something over EH. So EH first and last, AD first and last. Okay, and again, I'm just going back to this statement here to answer where this is going. All right, then it says if the measure of angle C is 127 degrees, what other angle is 127 degrees? So C's here, and this corresponding place is G. And so we know that the measure of angle G would have to be 127 degrees. All right, number two. It says, well, it gives us two rectangles here. It says, are the polygons similar? Explain. So first thing that we need to do is we need to make sure that we match up their corresponding sides. Now here's one thing that I always do. The largest side has to correspond with the largest side. Okay, so remember that, I mean, these are easy enough to get confused between the orientation, but the way that you can set it up, I think the most safe way is to say, okay, what's the longest side here? How does it correspond with this longest side? Okay, so I'm going to make a ratio and say 18 over 30 and simplify it. 6 goes to both of these. That means it simplifies to 3/5. Okay, and now I have another ratio, the second longest side, and they're rectangles, so these are all the rest of the sides. 15 over 25. 5 goes into both of these, 3/5. Are the polygons similar? Yes, they are. Here's my explanation. What are the two things we need for similarity? Congruent angles, and we'll notice that both these are rectangles, all the angles are 90. Yes, we have congruent angles. And proportional sides. Okay, and that, because we have proportional sides, we'll be able to make a similarity ratio. Okay, it says if they are similar, write the similarity statement and similarity ratio of the first figure to the second. So my first figure to the second means I'm going to write J, K, L, M first. Not necessarily in that order, but I'm going to write that order. So J, K, L, M. So I go from short side to long side. So I'm going to make sure I do the same thing here. Short side to long side, I'm going to say QN OP. So JKLM is similar to QN OP. What is my similarity ratio? Well, we really already had to find that in order to kind of to say if they're similar or not, right? We want to make sure our similarity ratio or their corresponding parts reduce down to the same value. This value is the ratio. Okay, 3/5. Okay, since we went from the first figure to the second figure. First figure 3, second figure 5. So there we go. Number 3 says use the diagram below to answer the questions. It told us that QM is parallel to AK, so these two are parallel to each other, and SV is parallel to PC. Then it also gives us this information so we don't have to think about it anymore. These two are parallel. The two are similar. The two polygons are similar. So we're going to write a similarity statement. I'll start with the larger one, QMAK. It's similar to, and then I'm going to use the base of the trapezoid. That's the shortest one first. So here, it seems that this should be the base of the shorter trapezoid, right? All right, we can see that V is down here at the bottom. The shorter or smaller, since it's going inside, right? It's going in, should be this one. So I'm going to say CP SV. Remember that we want to either name it clockwise or counterclockwise, not like we're reading a book. So clockwise here, CPSV. Okay. All right. So now with that established, we can answer some of the other questions. It says, what's the value of measure of angle Q? So they told us that these two lines are parallel to each other and might have felt like, okay, why did they tell us that? But now this is why. We have parallel lines and a transversal that intersects, right? These two are same side interior angles, and so they should add up to 180 degrees. 180 minus 71 gives us 109. Okay, so after that now, this is 109. We have isosceles trapezoid. Actually, can answer a bunch of these questions. What does this tell us? This tells us that this is 118. And so since this is 118, I said isosceles. Since this is 118, this is going to have to be 62. And since it's a trapezoid, it has 4 sides, then that means that it adds up to 360 degrees. So I have 118 plus 62 plus 71, 360 minus 251 gives us 109. So this is 109. All right. Okay, so this other side should be 118, and this angle should be 62. And we should just make sure that we have A and S at the same spot. We do. We have M and P at the same spot. Yep, we do. Okay, great. So our similarity statement works. All right, so we found all these values, and now we can just answer them. What's the measure of angle Q? Well, the measure of angle Q is 109. What's the measure of angle M? The measure of angle M is 118. What's the measure of angle A? 62. The measure of angle S, 62. Measure of angle C, 109. Now to ask, what is the similarity ratio of the first figure to the second? Okay. Now we only know one set of corresponding sides. And that would typically be a problem for us to find or to use if we were trying to establish that the figures are similar. But since they told us that the figures are similar, then we can just use this information and say, okay, KA corresponds with VS, right? KA is 8, VS is 6. So our similarity ratio between these two should, since they're similar, should be the same throughout the two figures. That similarity ratio is 4:3. So 4:3. Now it says find the values of the variables I should see for proportions and work. And this is how you'll get that done. Since I know this similarity ratio is 4, then what I'm going, or sorry, 4/3. Then what I'm going to do is I'm going to say, well, this should be the ratio between any two sides. It's important for me to realize that I went from left to right, so I'm just going to call this the left one and this is the right one. And that helps me to organize that I put numbers from the left trapezoid up top and numbers from the right trapezoid in the bottom. And now I set up a proportion so I can solve for my unknown values. So if I'm trying to find x, x is in the right, I'm going to move it to the bottom. Its corresponding side length is QM, 6. And so now I have this ratio to solve. 4x equals 18. Divide by 4, x equals 4.5. Okay. I can do the same thing for y. Just change color so it's easier to see different. So again, my ratio, my similarity ratio between the two is 4/3. Y is in the large one. It's going to go up top here. MA corresponds with PS, 12. So now I have a proportion I can cross multiply that gives me 48 equals 3y. Divide by 3 on both sides, y equals 16. Okay, and so now I found my answers to those questions. I guess I could have done the work down there. Okay, but that's how you found it. We looked at our proportion, we saw that our similarity ratio was 4/3, and then we set up our ratios, our proportion to solve there. Okay. Final question says, what is the perimeter of each figure? Since we know these sides now, or actually, at least we found x and y, I can find x, what was x, 4.5. Okay, so the perimeter for this figure is going to be 4.5 plus all these 15, 27, 31.5. And the perimeter for the second figure, I need to find this side still, right? I'm going to just give it a variable z and say that 4/3 should equal z/9. Cross multiply 36, 3z, z is 12. So that gives me 2642. That backwards. Big one is 42. Small one is 31.5. Okay, so as we're here, we should look and notice that if we write the perimeters as a ratio, 42, 31.5, and that might seem funky here, but 42 divided by 31.5 it gives us 1.333333. And if you know anything about converting fractions or decimals to fractions, guess what? The perimeters are the same. The ratio between the perimeters is the same as the similarity ratio. Okay? And that is something that will always be true. Okay? All right, so that is similar polygons, using the similarity ratio, explaining why two polygons are similar or not, and then finding missing side lengths and angles with that information. See ya.